Hi, I'm Suraj. I'm an engineer at Grafana Labs. I built Grafana's synthetic monitoring product last 2 years or so. So this talk is more like the experience and the journey that we went through and the things that we saw in the wild while building that product. But before I go about that, I want to ask, raise your hand if you are familiar with synthetic monitoring. Okay. Raise your hand if you are using some sort of synthetic monitoring, any product. Okay, cool. Okay. I'll go over and do a quick introduction of synthetic monitoring. Everybody is using ChatGPT these days to explain things. So I asked ChatGPT what is synthetic monitoring. It gave me a nice explanation, but TLDR is, it's just you have a program that is outside your environment that tries to probe your systems from the external internet, just so that you get to see how your systems are doing from the outside world point of view. And in a way, you are kind of trying to simulate the user behavior, but again, you never really can simulate 100% user behavior. So yeah, that's synthetic monitoring. Another question is, like, we have all the observability tooling, I got OTel, there are so many nice tools that tell me about if my system is down or not. Why do I need synthetic monitoring? Like, can I just not use it and be okay with it? My answer to that is, you instrument your service and that tells you about how your service is doing. But there are a lot of factors that are outside your system that can impact your service. Raise your hand if you've seen a certificate expiry or dealt with certificate expiry. Yeah, okay, yeah. Another one is, DNS misconfigurations, yeah. The classic one. So if you have synthetic monitoring, it's easy to find these things. So I'll just go over the terms that I'm using in this talk, just so that everybody is on the same page. When I say probe and agent, I'm referring to our synthetic monitoring agent. And public probe is, these are the probes that we host for you. We have 22 locations that are offered to everyone. So if you use our product, you'll get these probes. And private probes are ones that you host yourself in addition of these probes. And then check is the synthetic monitoring check that you define to check your services. We refer to service as a target. It could be a DNS. Like in this example, you see an HTTP check, but these checks can be of any types. DNS, TCP, ICMP ping, traceroute also. And region, if I say region, I'm referring to Grafana Cloud's region. So you can have Grafana Cloud in multiple regions, and I'm not referring to cloud provider regions here. Okay, another term that I'm using is POP, like point of presence. So these are the tiny clusters. We call them POP clusters. Okay. So now the terms are out of the way. We can just talk about the product first. Like how Grafana's synthetic monitoring is designed. So it's relatively simple. There is an API that knows everything. You create a check, goes and gets stored in a database. You use Grafana as a UI to talk to that API, but we expose API via Terraform and a bunch of other tools as well. So you can use any other tools to create and configure your checks. And then there are probes. As you can see, there are many probes that are connected to the API. That includes the one that we host and one that you can host as well. So all these probes connect up to API and ask for the work. They don't know anything about who you are. They are workers basically. So they'll go and say, give me work. API replies with the work, and then they start doing that work, and whatever data that they generate by probing a target, they'll collect and then publish it back to Grafana Cloud. So even if API is down, the workers will keep doing work. They'll just not get updates. And once they're able to connect back to API, they'll try to pull new changes, whatever checks that were added or removed. So this is brief architecture of the product. And then Blackbox Exporter, right? So I talked about probes, right? And these probes are doing different type of checks. Blackbox Exporter is a popular open source system in Prometheus ecosystem. You can use that to have these checks. And our agent is built on top of Blackbox Exporter because it already has support for all these check types. And instead of reinventing the wheel, we are using Blackbox Exporter as a library. We added one more check type on top of it, but our basic checks are powered by Blackbox Exporter. So the concept is simple. You give it a target, you define your configuration. Okay, my check should fail if it does that, and you can pass on headers and like define if you want to use IPv6, IPv4, all the basic configuration that you need. And then it will go and execute that, and what you get is Prometheus metrics. Then you can just scrape them. So we just use it as a library, and then our agent basically collects those metrics after every execution and then sends them back. We also collect logs that are produced after executions. Logs are kind of important when you're trying to debug why your checks are failing from one location and you have no way to test it from that location. I'm sure you can use a VPN, but again, that failure might be intermittent and hard to reproduce. So logs are really handy to see why it actually failed. I want to touch on why we selected and why we used Blackbox Exporter as our core. Again, Prometheus, almost every company is using Prometheus in some capacity. Grafana as a whole is really big on Prometheus, and our cloud offering has Prometheus and among other things. But Prometheus metrics are really neat way to collect metrics. I love them. And I'm coming from Graphite world. If anybody remembers Graphite here. Okay, yeah, okay. Yeah, so they're just neat. And there are many more things to love about Blackbox Exporter. It has a IPv4, IPv6 support in it. You can configure credentials. You can configure regular expressions based on the response you get. Like check should fail if my header has this, and these things are really handy when you're trying to set up complicated checks. Like think about you have to craft a check to see if your CDN is working correctly or not. It's tricky, and these features really make it easy for you to configure a check. So we liked that flexibility, and we said like our users should also have that flexibility. So we took Prometheus and exposed all the like Blackbox Exporters configuration options and just made it easy to run. So now the another question is, the talk's title had global network word in it. Like why do you need a global network? Can't I just deploy a prober next to my application and then it's all good? I can go home. I mean, you can, but then you'll not get. I defined synthetic monitoring as we are trying to simulate a real user, right? And your real user doesn't live next to your application. It's somewhere using consumer grade network. All over the world you have users. Like hopefully many users. If your service is popular. So to simulate those users, you need to be outside the network, right? And Another thing is, if you deploy your probe on the same cloud provider as your application, so cloud providers are smart. They will route you through their preferred network, so you'll not actually go through public internet. So to actually go through public internet, you need to diversify and be present on multiple cloud providers. And sometimes you have to use smaller, less known cloud providers to actually not coincide where your users are. So like why multiple service providers? Like if I deploy my probes on AWS, majority of my customers are also on AWS, right? If I deploy in GCP, some of them are in GCP. And then what they'll see is that their application is healthy because they're not coming from the internet. So we have a good mix of cloud providers there. So if you schedule checks on our probes, one or other way, like you will end up coming through the public internet. And also, selecting a cloud provider, like Blackbox Exporter is nice. It allows you to configure a lot of things, and with that configuration comes flexibility, right? You can craft a check that does only IPv6 checks, and that's really hard to find in cloud providers. Many major cloud providers don't have IPv6. I mean, they do, but not in a way we need, right? We need to reach over to other providers over IPv6. Like outside. Sorry. Okay. No worries. Yeah. So there are a bunch of qualifying things that we look into a cloud provider when we are selecting a cloud provider, right? And as you can see, IPv6 in 2020 was around 30%, and now that's around 40 to 45%. One observation that we have seen is a lot of mobile users are coming with IPv6 only. So there is a very popular telecom operator in India called Jio, and they only give you IPv6, right? And like that's the default network configuration. Like not sure why they chose that, but like that means that if you don't support like IPv6 and if your users can't reach over IPv6, they'll have trouble reaching to you. So some cloud providers say they support IPv6, but when we run our checks, they'll not have ICMP pings over IPv6. So we can't do ICMP ping over IPv6, and we can't deploy a probe there. Like everything else, like nobody mentions nowhere that everything says IPv6 is supported, but in reality, it's a hit or miss. So you have to do your checks. Another thing we noticed is that some cloud providers will only support IPv6 on some regions. So you think that, okay, this provider supports IPv6, but when you go to test, you see the fine print that, okay, these regions are not supported, only like a smaller subset of regions are supported. So another problem, like we are providing a service to check if your application is up and reliable, right? If we ourselves are not reliable, then we can't really say that the errors that you saw were because of you or because of us, right? If our probe is unreliable, then you will not trust our checks, and then you will not use our product, right? So network stability becomes a really important factor for us, and I mentioned going to smaller cloud providers. When you go over to smaller cloud providers, you'll see this issue. Sometimes there will be random packet drops. They'll do network maintenance, and there is a 5-minute off window where there's no traffic, like everything drops. So you need to test for that as well. Even though IPv6 is there, everything is good, but if network is not stable, it's no use, Another one is capacity issue, like who here has run out of capacity, like trying to provision VMs like, oh, I see a few hands, right? There was a thread on Black Friday where somebody was trying to provision stuff on Azure and it ran out. We saw one more cloud provider running out of capacity actually this week. So when you use smaller cloud providers and use less known locations where there are not a lot of people are putting stuff, these cloud providers will run out of capacity. So that's another thing that we see. Also, let's say you tested your things, like it's good, network is good, IPv6 is working, everything else that you need is working. Sometimes, things can fail, even though it's reliable and available today, it might not be tomorrow. So we need to come up with a system to track and see, again, answer this question that, was that error that our customer saw because of our problem or because, the service that they were trying to monitor was actually down. So for that, we deploy a set of canary checks everywhere. Every location will have permutation and combination of various check configurations that you can use. And then it will constantly run those checks and push that data over to us. So, this graph shows you various checks that we configure and then use that data to see if somebody reported an issue, was that because of our problem and because of customers. Okay. So another thing is, I talked about region, right? Grafana Cloud is present in 9 regions today. So we do a regional deployment of every service where we deploy. And we have 22 probes, so 9 into 22, that goes 198. So we need to deploy 198 of these probes. So when we started out, we just used VMs, spin up a VM on a lesser known cloud provider, put the agent there, it's a dumb worker, connect back to API, and then you're good, right? But nobody else in the company had this requirement, right? Everybody runs on Kubernetes and bigger cloud providers. So our team ended up managing these VMs. And also, when we had to deploy, we would destroy that VM and recreate that VM. It was very simple setup that got us up and running, but it's not very ideal, right? You'll see a slight downtime and the IPs of these VMs will also change, right? And our customers use these IPs to allow list that, it's the product that our product is pinging them and not, someone else. So that was also a bigger problem. Also, single node can fail. It just multiplies, small team trying to build the product, should we manage these VMs or build our product, So we started looking for a solution and our requirements were very simple, we just need something that can tolerate node failures, has IPv6 support, can do security, basic security. We don't want somebody to craft a check that exploits us. Another one was, we've been using Kube, and Kube is really nice when it comes to deployment. There is a declarative deployment model. You can do rolling updates, and there is good tooling around it. And we wanted to have these, but these were not hard requirements. They were more nice to have requirements. Another major thing that we said, this is something that we don't really need. We don't need persistence because this workload was stateless. So you can just kill the worker, bring up another one, don't need to attach, detach disks, that was a really good thing that we didn't need because life becomes easy when your application is stateless. And state management is, again, turtles all the way down. We don't want to go there. So it was really nice to put that, things we don't need filter. So we looked at a bunch of stuff, like we can use Nomad, use Ansible to orchestrate all that stuff. We looked at Anthos also, didn't really see a fit. And then we also see if these providers that we were using have like managed Kubernetes. And after looking at all those solutions, we found that the best solution is to just run Kubernetes ourselves. And we settled with self-managed Kubernetes. The reason being is not every managed offering will give you dual stack configuration. So we wanted to configure Kubernetes to be dual stack. We don't care about persistence. Even if the cluster dies, like the workload is stateless, the cluster is also stateless. So we can just destroy the cluster and rebuild the new cluster, and that made our life easy. Because now we don't have to worry about, how will we upgrade this cluster? Like what if had Sidh goes down? You just TF apply and then cluster comes up, which is a really nice thing when you're managing a kube cluster. Also, like everybody in Grafana labs is using Kube to deploy their services. So everybody knew Kube. No need to learn a new tool, and our platform engineering team is well versed, and we have a lot of good tooling around it. So another big thing that this gave us is that uniform setup across providers. Like you just need bare VMs, get your VMs, and then you'll have a uniform thing on top of it. So another thing that we really liked in Kube is network policies. So we can just use network policies to secure this pod that this agent shouldn't be able to talk to these things and only should be able to talk to these things. And rolling updates, like they're baked in Kubernetes, and then there are tools like Argo workflows that you can use to do a gradual rollout. So what we ended up building was we deployed 22 clusters, like one cluster per location. And then for every region we deploy of Grafana Cloud, we create a namespace in that cluster. And we run agents that belong to that region in that namespace. So here you can see like Ohio has like 4 namespaces all belonging to different region, and then there are different locations. We used RKE with Terraform to, like RKE is Rancher Kubernetes engine. Like it's super simple, gives you a basic Kubernetes cluster without worrying about a lot of stuff. And we want to thank Rancher folks for open sourcing that. That's a really nice tool that we've been using it. And we used Calico CNI. I'll go over why we went with Calico later. And then we had a bunch of security concerns, right? Like you want to use Kube, but Blackbox Exporter needs netraw capability to do ICMP pings, right? And netraw is not recommended. Like you shouldn't grant your pods netraw capability if you're running on Kube. So this was a really big deal. Like if somebody can craft, like exploit it and craft a raw packet, and if they can reach to our control plane and internal services, then it becomes a big deal, like really quickly. So we wanted to secure off internal network and cluster components from these pods. So Calico has a concept of network policies. So we used Calico network policies to block off all private network. But the thing is, when you block a private network, your pods, they can't reach Kube DNS, right? So now you have no DNS. So everything fails, and you have to provide a DNS configuration in the pod to say that, like use an external public DNS that you can reach out to, and don't use Kube DNS. So we used public DNS, walled off everything that was in private network. So like looks something like this. I was talking Calico, right? The reason we went with Calico is because Calico allows you to have a policy that has an action attached to it, right? So in this policy, what I'm saying is that deny everything that goes to these networks. This includes, again, IPv6, right? Also, you need to wall off IPv6 as well. And then I'm adding a default action, because default is deny, to allow everything else. And I'm putting a pod selector, and it's saying like egress policy. So Kubernetes network policy has an allow action. So you can only allow things. In our case, we wanted to do opposite of that. Like we wanted to deny a certain group of CIDR and then allow everything else. So Calico made it super easy, and that's why we went with Calico as our CNI and used it. So now rollouts. So before, the rollouts used to be you destroy a VM, recreate a VM, IP changes, everything happens. Now the rollouts are simple. The cluster is stable. It has a fixed set of IPs. We can advertise that, and our customers can use that in their allow list. And we can just push a tag on GitHub that will spin up drone, build images, push those images, and kick off an Argo workflow. And that Argo workflow, what it does was it spins out parallel workflows for each region. So you'll just deploy to dev. You can see how it's doing. And then we have multiple locations. So we don't want to deploy everywhere at once, because that's the easiest way to get downtime. Like you miss one thing and then everything is down. So we wanted to do a staggered rollout where like you just release one location, look for metrics and see how it's doing, then release to two more, see how it's doing, and then release in batches. So we used Argo workflows for that, and we added a step in between to query Prometheus. So we would release one location first. It would go and query Prometheus and see if the agent with that new version came up, query the metrics, and if it's healthy, it will proceed and go deploy two more, and then it will wait for an approval. So every production cluster region, you just give it an approval, it will deploy two, one and then two, and then it will wait for one more final approval. And then once you give that approval, it will go ahead and deploy like the rest of these locations in batches of 3. So it will deploy 3, wait for metrics to show up, and it halts if it doesn't get metrics. Like if it can't query metrics or if the metrics are not available, the rollout will stop there, and you can resume from there. But if something goes wrong, it'll just stop there, like no more damage. So that's really nice. And again, Flux is used to deploy, like do the final sync. So like here is how it looks like in action. So really, like you feel like you're traffic controller when you're deploying this. So here you see it's waiting for approval, and then like these process. So it's waiting for approval, and then it checked for these 3 locations, and it was green. So went down, checked for more location, and then it's deploying for more location. So here is how it looks like in action. So you see around 11, like one location of a region came up, and then slowly the whole region came up, and then over a span of few hours, we gradually rolled it out across this, right? And also the manual deployment, like rebuilding of nodes, it's a time-consuming process, right? You need to rebuild nodes and then make sure everything is up and running. And here you can just approve and then just watch this while you work. You don't even need to watch at most times, because you have a confidence after you see a few locations that it's working fine. So that frees up your engineering time, and now release becomes like super easy instead of a dreadful process. So now back to lesson learned. Internet, like it always works for us, but parts of internet are always reliable, always like unreliable, always changing. So there will be an outage somewhere. You just don't know of it because internet will route you around it. It's not noticeable unless you go looking for it. Another is adding redundancy where you can, like I talked about public DNS, right? But if you configure only one public DNS and that DNS goes down, you're down. So you need to like add redundancy where you can, you can't add everywhere where but there are some places where you can add without adding extra cost. So you should add redundancy where you can. Another is like service providers. When you have a diverse set of locations and diverse set of service providers, someone will be doing a maintenance in some region or other. When you're using one region, you don't see that maintenance that often. But it becomes very frequent when you have that. So communicating that to your users, because sometimes it is inevitable that they'll see a network reset or packet loss or something or the other weird behavior that latency shot up when provider was doing maintenance. So if you communicate that through your status page or however you want to do it, customers will know that, okay, it's not my service that was degraded at that time. Builds that extra confidence. Another one is like good defaults and educating your users. Talked about one location being unreliable, right? And if you schedule your check to only run from one location and then configure a very aggressive alert on it, you'll be woken up by a pager middle of the night. And we don't want our users to have that experience. So we try to nudge them to use more probes, that you should use at least 3 probes so you don't get woken up in the night by a false alert. So another one is like limits and abuse. I was talking about DNS, right? Before we used the public DNS, we used to rely on cloud providers' DNS when we were deployed on VMs. And if you do a lot of DNS queries, the providers will get angry and send you an angry email saying that, stop whatever you're doing, which is fair on their point of view. But our product, we can't cache, right? If we cache DNS requests, then we are not actually checking, right? So that defeats the whole purpose of the product. So that's something. And another one is, people will get angry if you check their URLs. Somebody configured a check against a website and then they'll write an email saying that, why are you probing my website? Sometimes it has happened that different departments, they didn't knew that they were using our products, and then we got an angry email saying that, why are you probing me? So another one is every check has a cost, resource cost associated with it. If you create a check, it'll need to be run, scheduled, and everything. Sometimes engineers make mistake and they end up writing a script that will create a lot of checks, essentially probing the same target. Then you don't want that to happen. So we have limits in place to make sure that you don't create a lot of checks at once. And that has saved us a few times. Another one is being verbose. What I mean by verbose here is that you are probing people over the internet, right? And there are a lot of products out there. It is essentially a bot, right? It's a good bot, but it's a bot. And people use bot protection. Cloudflare has a famous bot protection product, and there are many other bot protection products out there. And they'll just flag you off that, this thing is trying to probe you again and again. It's a bot, and you'll be blocked. So if you are verbose in your user agent headers and publish your IPs, that okay, these are our IPs, they belong to this product, people will be able to come back to you instead of just blindly blocking you. So we publish full user agent with the URL that you can use to contact us, which is nice instead of just getting blocked. DNS, right? When we were deploying on VMs, we didn't think about DNS, right? That was an implicit dependency, and they were not happy about overloading that DNS. So being mindful of your implicit dependencies. Like it is a dependency, you don't maintain it, but if you're mindful of that, it's another big lesson. And that's all.